Section 3.4 deals with the algebraic properties of logs. So we sort of peeked ahead and used a few of them when we were doing some of the previous problems. But here we're going to really dive in and look at some problems where we've got to make sure we can work with expressions and combining and breaking apart logs. So for your convenience, they've all been put at the top here. Notice that in order to do these separations and combinations, the bases have to be the same. And remember that the log and the exponential are inverses of each other. So when we were solving the exponential functions, we took the log of both sides to plug it into the inverse. But now you're going to see if we want to eliminate a log expression from a problem, we actually have to plug the log into the exponential function. So example 11 says solve this expression for x. So I want to show you in my classes and a lot of students when I've tutored, the very most common wrong step that people do is step 1 on this problem. So they would read this and they would see that, oh, log is log base 10. And then they would say, well, I'm just going to raise everything over 10, okay? All right, that is absolutely not a legal move, okay? Whatever you do to one side of the equation, you have to do to the other, but you can't raise. If you raise this over 10, you're raising the whole thing over a 10. This does not distribute across like this. So we actually have to do a little bit of algebra before we're ready for that step. So I need to combine all of the logs into one single log expression. So up at the top here, we see that if we have log of something plus log of something else, as long as their bases are the same, we can combine them by multiplying the expressions inside together. So I'm going to apply that property, and I'm going to say, well, log of this plus log of this is log of x plus 21 times x. So I'm only using the brackets, that way we can see that these two expressions are both inside that log. This equals 2. And just to make this a little simpler, I'm going to go ahead and distribute this x across. So now if I want to eliminate the log from the expression, I can raise each side over the base. So that would be the equivalent when I write this of I'm plugging log base 10 into 10 to the x. So if I do it to the left, I have to do it to the right. Now it's a legal move. So this is going to eliminate the log and leave me with x squared plus 21x, and 10 squared is 100. So it looks like I've got a quadratic, so I'm going to move everything over to the left side and set it equal to 0. This is definitely a quadratic, and it looks like something I could factor. So what two numbers multiply to 100, but either add or subtract to give you 21? And so 4 times 25, right? 4 times 25 is 100. 25 minus 4 is 21. So I know this is going to be x and x. I know I'm going to have 25 and 4. And I want these to multiply to be negative, but add up to be positive. So I'm going to make the bigger number 25, the positive number, the smaller number 4. So now I have 25 minus 4 gives me positive 21. And negative 4 times positive 25 give me negative 100. So now I get that x equals 4, or x equals negative 25. So this is a very important part of the problem. Just getting to the number, you are not done, because logs have domain restrictions on them. So we have to go back and look at the original form of the equation and make sure that these answers are valid in this expression. So logs, the number x, when you plug it in, the expression cannot be negative and it cannot be 0. So 4 is going to be okay, because 4 plus 21 is 25, and 4 works. But negative 25, well, negative 25 is going to give you a negative 4 and negative 25. So we actually have to throw out the negative 25 is an invalid solution, and the only correct answer is x equals 4.